let's look at expectations. Let's look at expectations. So I've popped, let's see if I can do this, up there. Oh, my finger ran out of space. Okay, we've got our definitions up here, but what is the expected value? And again, this sort of comes up in single maths as well. We're looking at the idea of an average. So the idea is this. Discrete random variables like this is basically I roll a dice that has 5 sides somehow that has these weird probabilities. Whatever it is, I'm generating numbers. I'll get a -1, a 5, a -3, a -3, a 7, a 1. You generate lots of them. If I do that a lot, and I mean a lot, and find the mean of those numbers, we should get the expected value. All right. So E of x is the sum of the x value times the probability, which is very much like finding a mean from a frequency table. You're telling me 2? Do I believe you? Of course I believe you. -3/4. The 6's cancel out. I get 5/12. I get 7/3. Let's put it all over 12. -9 plus 5 plus 28 over 12 is 2. Very nice. Now, path is on a mission. E of x squared. Now, we've got this up here. The expected value of any transformation of x. So all we're saying is, well, what if I was to square all the values of x? What if I was to square them? What's the expected value of that? So I generate values of x, I square them, then I take their average. Well, let's just see. Let's just square the values of x and take their mean, essentially. 9 times 1/4 plus 1 times 1/6 plus 1 times 1/6 plus 25 times 1/12 plus 49 times 1/3. At what point does doing mental math become inefficient? Let's get out the big boy. Let's get out the big boy. Let's reset everything. There we go. 9/4. I mean, having said that, plus 2/6 plus 25/12 plus 49/3. Did I type that incorrectly? That looks okay. 21. Woo! 21. Okay. By the way, I'm going to bring this up multiple times today, and I know it's not possible for everyone, but if it is within your ability and means, especially if you're doing stats as a module, I highly recommend investing in a CG50, the graphical calculator. It is so helpful for doing the stats in particular. And if you are doing further maths A level, there's every chance you are eyeing up a further, like a STEM subject at uni, and I think you'll find the CG50 very, very useful for that. Now, 3 and 5 are slightly different. Now, the idea is that this is linear. All right? This is linear. 2x minus 1. So what that means is, in fact, I can split up what I've got. So I can multiply out essentially the expected value. So it's a little bit quicker. Now the expected value of x is 2. We already established that. And the expected value of 1, well, if I generate a random number and it always comes out as 1, right? So it's basically not random. It's just a number that's 1. So every time I generate this thing, it's going to be 1. The average value is just going to be 1. So that comes out as 3. Four, on the other hand, we can't. All right. Why? Why can I not do that? because 1 over x, that is non-linear. Okay, that's not linear. So that is not equal to 1 over e of x. So we can't do that. Okay, so there's a huge difference between a linear, the expected value of a linear function and a non-linear function. Now, annoyingly, I've got to go minus 1/3 times a quarter plus 1 over minus 1 times 1/6 plus 1 over 1 times a sixth plus 1 over 5 times a 12th plus 1 over 7 times 1/3. Path has got an answer for me. Of course, Path does, but does anyone else have a check for me before I slowly and laboriously type things onto my on-screen calc? Does anyone want to do the check for me on this one? Come on, crew. Iad seems to agree with Path. We just need to plug it into the calculator. Let's find out. Go on, one more check, please, gang. Someone put it into your calc. Let's do this. It's a Sunday morning, first Sunday of the break. Let's do this. Come on. Someone's got to be frantically plugging these numbers into their calculator as we speak. Otherwise, I'll ask Josh to do it. Oh, there we go. You've all done your calculators at the same time. So minus 2 over 105. There we go. Oh, Turan. Oh, how is it? How are you not on break yet? That's insanity. Right. Now the last one, e of 3 minus x, is nice and easy because that is in fact linear. So I can say that that is 3 minus the expected value of x, which is 3 minus 2 equals 1. So interesting question there, Bob. How is the mean negative? I mean, that's no problem, is it? If you take the average of some numbers, and some of them can be negative numbers, right? The values of x that we are taking the mean of can be negative, right? So there are negative values of x. Yes, Alan. Yeah, absolutely. All right. The expected value doesn't have to be positive. It does depend massively on what kind of values of x we get. Now, don't get me wrong. As we go through more of these, we have a tendency to use discrete random variables that only take positive values, like a binomial, like a Poisson, like counting distributions, right? All the ones we have in this course are counting distributions: Poisson, binomial, geometric, negative binomial. All right. But there's nothing to say that we can't come up with our own discrete random variables that can take negative values, so you can have negative expected values. All right, that's not a problem. And yeah. All right, and by and large, we had a positive e of x because we've got 5 and 7, which are much bigger than the negative values of minus 3 and minus 1. However, when we take the expected value of 1 over x, that flips round. 1 over 5 and 1 over 7 are smaller in relative size than minus 1/3 and minus 1. Okay?